Hello class, today we're going to talk about section 9.7, which is exponential growth and decay. By the end of today's lesson, you'll be able to identify and solve three different types of problems: growth problems, decay problems, and compound interest problems. So our first one is exponential growth. This is an exponential function. Remember that graph that we looked at yesterday where we have that rapid increase, where the amount increases by the same percent over time. Our formula for this is y is equal to a parentheses 1 plus r to the exponent of t. Breaking this down, a is our starting amount. So this is our initial value, the starting amount that we have. 1 stands for 100%. That is always going to be staying the same. R stands for your percent of change, and that needs to be written as a decimal. So it must be that percent written in decimal format. T is going to be the amount of time, paying careful attention to the actual units that they give it to you in. So, for example, a radio station has sponsoring a contest. The prize begins at a $100 gift card. Once a day, the disc jockey announces the name, and the person has 15 minutes to call. If the person does not call within the allotted time, the prize increases by 2.5%. So the first thing we want to do is write an equation. This is going to happen for all of your problems, whether it's written out in an A-B format like this or not. The first step is always to write the generic equation. This is the expectation on the homework as well as the expectation on the test. So our first problem is going to write the equation to represent the gift card amount in dollars after T days with no winners. So looking back at our information that they give us, we are starting with a $100 gift card. So that's going to be our A value. Then it also says it increases by 2.5%. We want to turn that into a decimal for our purposes, so moving the decimal places 2 to the right, I get 0.025. Then it's asking us for T days, so that's just going to be our general variable right now. So you would write the equation out to say y is equal to 100 in parentheses 1 plus 0.025 to the t power. It's not giving us a specific number of days, it is just asking us for the general equation. Part B, however, asks, how much will the gift card be worth if no one wins after 10 days? So now is when you are actually going to plug in that value for t. Same equation as before, but now we are looking at 10 days. When you plug that into the calculator, you're going to type 100, and then in parentheses, 1 plus 0.025, let's start over. So we have 100, and then in parentheses, 1 plus 0.025. Close the parentheses, then the caret button, and then 10. It is crucial that you close those parentheses, otherwise the exponent will only go to the second number and will not be put on the 1. So, our final answer for this is $128.01, making sure that you are rounding to 2 decimal places when it is money involved. Go ahead and try this one on your own. So we have our initial value of 10,850 plus times 1 plus that 5% written as a decimal to the exponent of 15. Your final value is going to be $22,556.37. Next type of problem that we have is a compound interest. This is a specific type of exponential growth problem that deals with interest, whether it is on a loan or on a bank account or anything like that. We are using this type to get interest not only on the initial value, but also on previously earned interest. So this equation breaks down into A is equal to P parentheses 1 plus R over N, and then close the parentheses to the NT power. For this equation, our initial amount, or what we call the principal, is the p-value. So again, that's the starting amount. That 1, again, stands for 100%. The R still stands for our rate, or our percent. And it still is written as a decimal. It is always written as a decimal. The N. N stands for number of times compounded. So that's the number of times you are actually going to be calculating this within a 1-year period. The N in the exponent is the same as the N in the denominator. That T stands for time. This is always going to be in years. So when you're using compound interest, the time is always in years. One more thing I'm going to note on this N value. There are some key words that you're going to be looking for within these problems, such as annually. That's going to tell you the N value is 1. Biannually is going to tell you that the N value is 2. Quarterly is going to tell you that the N value is 4. And then if we have monthly, our N value is going to be 12. So these are just different words that you are going to pay attention to that might help you indicate what the N value is. So for this first problem, Maria's parents invested $14,000 at 6% per year, compounded monthly. How much money will there be in the account after 10 years? So we are looking again to break down our initial information. We have our starting value of P. We're going to change our percent to a decimal. And then we are compounded monthly, which tells us that our N value is going to be 12. And then we need to know for 10 years. That's our T. So we're going to break this down. A is equal to $14,000. In parentheses, 1 plus 0.06 divided by 12. Close the parentheses, and the exponent is 12 times 10. When you put this into the calculator, you must be careful that you include the proper amount of parentheses. So in the calculator, you would type 14,000, parentheses, 1 plus 0.06 divided by 12. Close those parentheses. Caret, and then you need 12 times 10 in parentheses again. If you would like to prevent having to do that second parentheses part, you can simply solve this value right here and just put it to the 120th power. So if you do not solve that multiplication before you plug it into the calculator, you need that second set of parentheses. If you do solve it first, then you do not need that second set of parentheses. So plugging this into the calculator, it's going to give me my final answer of $25,471.55. Again, rounding to 2 decimal places and including that dollar sign as the label. Go ahead and try this one on your own. Initial value of 300, 0.035 is your percent after you turn it into a decimal. Again, compounded monthly, so that N value is 12 and 22 years, giving you a final answer of $647.20. Last thing we need to talk about is exponential decay. This is similar to the exponential growth, but now instead of adding things on, we are subtracting them. So A is still our initial value, or that starting amount. 1 still stands for 100%. R is still your rate, or your percentage, written as a decimal. And T is still your amount of time. So very similar. The only thing that changes between growth and decay is whether it is adding or subtracting in the middle. So a fully inflated child's raft for a pool is losing 6.6% of its air every day. The raft originally contained 4,500 cubic inches of air. So breaking this down, 4,500 being our initial value, 6.6% being turned into a decimal for our equation purposes. So writing our equation, we have y is equal to 4,500. And then in parentheses, 1 minus 0.066 to the t power. It hasn't given us an amount of days yet, so we just plug in a variable. For the second part, it tells us that we are looking at 7 days. So we have our same equation, just plugging in 7 for our exponent, and we are going to get a final answer of y equals 2,790.23 cubic inches of air. So just plugging in those values into the formula. Go ahead and try this one on your own. Changing that percent into a decimal at 0.003, so we're subtracting that from 1 with our initial population that they give us, and using 10 for the years, because that is the difference between 2000 and 2010. Notice, if you typed a decimal in for your answer, technically that is not incorrect. However, we do not count tenths or hundredths of people. We round to the nearest whole. With people, we always make sure we round down. So the most correct answer is 86,023 people. If you have questions about this or anything else from the lesson, please let me know when you get to class.